When Pluto was reclassified as a dwarf planet in 2006, many believed it was just a lifeless, frozen rock at the edge of the solar system. But recent declassified images from the James Webb Telescope have turned that assumption on its head. What these photos reveal is more than extraordinary, it's downright terrifying. Pluto's icy heart, once thought to be a serene landscape, may be hiding a secret that has left scientists baffled. What could be lurking beneath its frozen shell, and why does this discovery challenge everything we thought we knew about our solar system? One of Pluto's most iconic features is its heart-shaped glacier, Sputnik Planitia, a region so massive that it's reshaped the dwarf planet's orientation. But what lies beneath this icy surface is even more fascinating and potentially ominous. Scientists now believe that beneath this glacier lies a hidden ocean of liquid water, insulated by the thick layer of nitrogen ice. This isn't just any ordinary ice field. It's an active, dynamic system with patterns of convection moving and churning like a frozen lava lamp. What could be fueling this activity so far from the Sun? Radioactive decay in Pluto's core may be generating enough heat to keep this ocean from freezing solid. But the presence of water raises an even more profound question. Could life exist in this frigid, alien environment? Pluto isn't the static, frozen world we once imagined. Declassified photos reveal massive tectonic features, suggesting that the dwarf planet is geologically active. These cracks and faults indicate that Pluto's crust is flexing and moving, an extraordinary phenomenon for a world so far from the Sun. The massive glacier has even caused Pluto to shift its orientation, aligning itself with its largest moon, Charon, in a gravitational dance that defies expectations. This level of activity raises chilling questions. What forces are at work beneath Pluto's icy exterior, and could they point to something far more sinister? The discovery of a subsurface ocean on Pluto is not just surprising, it's groundbreaking. Water is a critical ingredient for life, and its presence here forces scientists to rethink the boundaries of habitability. If life could exist on Pluto, it could exist on countless other icy worlds across the galaxy. But Pluto's ocean is different, shielded by miles of ice and bathed in perpetual darkness. Any life here would need to adapt to extreme conditions, conditions that might produce organisms unlike anything we've ever seen. Renowned physicist Brian Cox has suggested that even the simplest microbial life on Pluto would redefine our understanding of life in the universe. But what if the truth is even stranger? What if Pluto's ocean isn't just a cradle for life, but a harbinger of something far more ominous? The James Webb Telescope has detected unusual thermal patterns and chemical anomalies that hint at processes we don't yet understand. These compounds, often associated with biological activity, have raised concerns about what might be thriving beneath the ice. Could these be signs of simple microbes or something far more complex, something potentially hostile? The possibility of advanced, resilient organisms adapting to such extremes raises unsettling questions. Could life on Pluto represent a form of survival so alien that it challenges our very concept of biology? Pluto's potential ocean might be the result of a violent birth. Recent studies suggest that Pluto formed rapidly and chaotically, with massive collisions generating enough heat to create a liquid ocean. Over billions of years, radioactive decay has kept this ocean from freezing, but at what cost? This fiery beginning might have sown the seeds for a cold, enigmatic world teeming with unknown potential or hidden dangers. As scientists unravel these mysteries, one thing becomes clear. Pluto is not just a frozen relic of the Kuiper Belt. It's a dynamic, complex world with secrets that could change everything we know about life in the cosmos. Pluto's surface isn't its only enigma. The James Webb Telescope has also revealed striking details about the dwarf planet's thin atmosphere, unlike anything found on Earth. Pluto's atmosphere is primarily composed of nitrogen, with traces of methane and carbon monoxide. This haze is produced by complex chemical reactions in Pluto's upper atmosphere, driven by the weak sunlight that reaches this distant world. These reactions result in the formation of organic molecules known as tholins, which give Pluto its reddish hue. But the presence of tholins raises an unsettling question. Could these molecules be a precursor to more complex organic compounds, compounds that might, under the right conditions, support life forms adapted to extreme environments? Pluto isn't alone in its journey through the Kuiper Belt. Its massive moon, Charon, plays a crucial role in shaping its mysteries. Together, Pluto and Charon form a binary system where their gravitational pull influences each other in ways unseen anywhere else in the solar system. Charon's surface features mirror the complexity of Pluto itself, with massive canyons and tectonic activity suggesting a dynamic history. But the red polar cap, likely formed from methane escaping Pluto's atmosphere and freezing on Charon, hints at a strange and interconnected relationship between these two worlds. Could Charon be influencing the activity beneath Pluto's surface? And what does this interdependence mean for the possibility of life, or other unexplored phenomena, within this binary system? Pluto is just one member of the Kuiper Belt, a region teeming with icy worlds and fragments left over from the solar system's formation. But why does Pluto stand out? Why does this particular dwarf planet display such unique characteristics compared to its neighbors? While other Kuiper Belt objects remain mostly static and inert, Pluto is alive with activity, from its shifting ice fields to its thin atmosphere. Could this suggest that similar processes are occurring on other distant worlds hidden in the shadows of the Kuiper Belt? The discoveries on Pluto may just be the beginning, offering a roadmap to uncover the hidden dynamics of these distant, frozen realms. The revelations from the James Webb Telescope have opened a new chapter in Pluto's story, but they've also raised more questions than answers. To truly understand this icy world, we'll need to send missions capable of exploring its surface and subsurface in unprecedented detail. NASA's New Horizons flyby in 2015 provided a groundbreaking first look, but future missions will need to go further, analyzing Pluto's subsurface ocean, its dynamic atmosphere, and the chemical mysteries that hint at life. With advancements in technology, humanity is closer than ever to unlocking the secrets of Pluto and understanding its place in the broader narrative of our solar system. Could this dwarf planet hold the key to questions about life, planetary evolution, and the mysteries of the Kuiper Belt? One of the lesser-discussed enigmas of Pluto is the possibility of a magnetic field, a phenomenon that could change how we understand the dwarf planet's behavior and its potential for habitability. While evidence is still initial, scientists have noted anomalies in the data that hint at magnetic activity beneath Pluto's icy surface. On Earth, our magnetic field protects us from solar radiation and helps maintain a stable atmosphere. Could a similar mechanism be at play on Pluto, shielding its subsurface ocean and atmosphere from the harsh environment of the Kuiper Belt? If confirmed, a magnetic field on Pluto could explain some of the unusual thermal and atmospheric patterns detected by the James Webb Telescope. It might also provide a framework for understanding how distant, icy worlds can maintain such dynamic systems. Pluto's location at the edge of the solar system places it in a region influenced by unseen forces, from the gravitational pull of the Sun to the subtle but significant interactions with other Kuiper Belt objects. These forces may play a crucial role in shaping Pluto's unique behavior. Some scientists theorize that Pluto's geological and atmospheric activity might be driven, at least in part, by these gravitational interactions. Periodic tugs from neighboring objects could generate heat within Pluto's core, fueling the processes that sustain its subsurface ocean and icy surface features. These gravitational dynamics also raise the possibility that Pluto has experienced close encounters or collisions in its distant past, shaping its surface and leaving behind clues to the forces that govern this frozen frontier. Pluto, once dismissed as a cold, lifeless dwarf planet, has proven to be anything but ordinary. The James Webb Telescope's declassified images have revealed a world brimming with complexity, dynamic glaciers, mysterious atmospheres, and the tantalizing possibility of a hidden ocean beneath its icy surface. This small, distant world challenges our understanding of what a planet can be, reminding us that even in the coldest corners of the solar system, there is motion, transformation, and perhaps the spark of life. These revelations push us to ask deeper questions. Could Pluto's hidden ocean support life? What do its tectonic features tell us about the forces shaping icy worlds across the cosmos? And what secrets are waiting to be uncovered in the Kuiper Belt? Pluto is not just a relic of the past. It's a window into the dynamic processes that govern our solar system and beyond. As we look to the future, the tools we build and the missions we design will bring us closer to uncovering the truths hidden within this enigmatic world. What do you think Pluto is hiding beneath its icy surface? Share your thoughts in the comments and subscribe for more cosmic discoveries. The journey to understanding Pluto is far from over, but one thing is clear. This frozen world has ignited a fire in our imaginations, urging us to keep exploring, keep questioning, and never stop reaching for the stars. Until next time, stay curious and keep looking up.